Hello, and welcome back to AI Ed, From Bits to Breakthroughs. I'm your host, Jeff 1.0, one of the AI-generated avatars here at newbits.ai. Crafted from bits and powered by artificial intelligence, I'm here to guide you through the frontiers of AI, where groundbreaking discoveries are shaping the future of technology. In our last episode, we introduced AI Frontier, navigating the cutting edge, setting the stage for this journey into the most advanced AI developments. Today, we take a deep dive into the breakthrough research driving AI innovation, from cutting-edge model architectures to transformative training methodologies and scalable AI applications. Artificial intelligence is evolving at an unprecedented pace, with research breakthroughs emerging at an accelerating rate. Whether in large language models, multimodal AI, reinforcement learning, or AI for scientific discovery, research teams across academia, industry, and government are reshaping the boundaries of AI capability, often in ways that were unimaginable just a decade ago. AI research has undergone a fundamental transformation. Gone are the days when academic institutions were the sole drivers of AI discovery. Today, the field is powered by a dynamic ecosystem where academic institutions, corporate research labs, and global initiatives work in tandem, each pushing the limits of AI innovation. Some of the world's leading AI research centers include Google DeepMind, advancing scientific discovery, multimodal AI, and reinforcement learning. OpenAI in partnership with Microsoft, pioneering large-scale models and enterprise AI solutions. Anthropic, leading development in AI safety and aligned systems. Stanford's Center for Research on Foundation Models, CRFM, focusing on the validation and evaluation of large-scale AI models. MIT Computer Science and Artificial Intelligence Laboratory, CSAIL, pioneering fundamental AI methodologies. Berkeley AI Research, BEAR, advancing machine learning and robotics innovations. The collaboration between academic and industry researchers has led to breakthroughs that bridge theoretical understanding with real-world implementation. Joint projects like Stanford's partnership with Microsoft Research on foundation models and Google's collaboration with NASA on climate modeling demonstrate how these synergies accelerate progress. One of the most significant research shifts in recent years has been in AI model architectures. The introduction of the transformer by Vaswani and his colleagues in 2017 revolutionized natural language processing, but research has not stopped there. Recent breakthroughs have pushed AI systems into entirely new frontiers of capability. Key architectural innovations driving this progress include multimodal architectures from Google DeepMind, systems that seamlessly process text, images, and audio in a unified framework, enabling richer human-AI interaction. Constitutional AI systems from Anthropic, architectures that embed ethical guardrails directly into model design, ensuring safer and more transparent decision-making. Zero-redundancy optimization from Microsoft Research, advanced training techniques that drastically reduce memory requirements, making large-scale AI development more accessible. Enterprise-grade architectures from Microsoft OpenAI, scalable systems optimized for real-world business applications, from document analysis to code generation. These advancements have not only refined AI's core capabilities in generating text, images, and code, but are actively transforming industries. From robotic surgery and predictive healthcare systems to autonomous logistics and creative content pipelines. AI is not just about bigger models, it's also about smarter training. Researchers are constantly refining methodologies to balance capability with efficiency, reduce computational costs, and align AI systems with human values. Recent breakthroughs in AI training include chain-of-thought prompting by Google DeepMind and Stanford, a technique that enhances models' problem-solving abilities by encouraging them to generate intermediate reasoning steps, leading to improved performance on complex tasks. Constitutional AI by Anthropic, a training approach that instills AI systems with a set of guiding principles, enabling them to self-supervise for harmlessness and helpfulness without extensive human oversight. Memory-efficient training by Microsoft Research, optimization methods that dramatically reduce hardware demands while scaling to large models, exemplified by the development of the Phi 3 model designed to operate efficiently on local devices. reinforcement learning from human feedback utilized by OpenAI and Google DeepMind, techniques that enhance AI performance by incorporating human preferences and feedback into the training loop, refining AI behavior through real-time user input. These innovations are reshaping how we develop AI, not just making systems more powerful, but also more transparent, sustainable, and responsive to societal needs. While many AI advancements focus on language models and image generation, some of the most transformative breakthroughs occur at the intersection of AI and fundamental science. These innovations are not merely automating tasks, they are redefining the possibilities of human discovery. Recent milestones in AI-driven science include AlphaFold by Google DeepMind. This AI system accurately predicts protein structures, facilitating the understanding of molecular interactions and accelerating drug discovery for diseases such as Alzheimer's and cancer. AI-driven material discovery at UC Berkeley. Researchers employ AI to design novel materials, such as covalent organic frameworks, enhancing clean energy storage and carbon capture capabilities. GenCast by DeepMind, an AI model that delivers weather forecasts up to 15 days in advance with unprecedented accuracy, aiding in disaster preparedness and climate resilience. Quantum AI simulation tools by IBM and NASA. Collaborative efforts have led to AI models that significantly expedite the analysis of complex quantum chemistry problems, surpassing traditional computational speeds. Neural rendering by NVIDIA. Advanced AI techniques that create photorealistic 3D environments in real time, enhancing applications in robotics, virtual training, and simulation. These advancements showcase AI's role as a collaborative partner in science, not just a tool, but a catalyst for solving humanity's greatest challenges. Despite the rapid pace of AI breakthroughs, significant challenges persist. These hurdles are not solely technical, they encompass societal, ethical, and environmental dimensions, influencing how AI evolves and integrates into our world. The most pressing challenges include massive compute demands. Training advanced AI models necessitates clusters of specialized accelerators, requiring substantial computational resources and infrastructure. Organizations like NVIDIA and Google are at the forefront of developing hardware and software solutions to meet these demands. Bias detection frameworks. Advanced testing protocols developed by entities such as Anthropic and academic institutions like Stanford University aim to identify and mitigate discriminatory patterns in AI decision-making, promoting fairness and equity. Energy-efficient training. Researchers at institutions like Microsoft Research and MIT are pioneering techniques to reduce power consumption during AI model training, striving to maintain performance while enhancing energy efficiency. These efforts are crucial in addressing the environmental impact of AI technologies. Navigating evolving policies, such as the UK's proposed Public Authority Algorithmic and Automated Decision-Making Systems Bill, emphasizes transparency and accountability in AI systems used by public authorities. Similarly, in the United States, the blueprint for an AI Bill of Rights outlines protections to guide the ethical development and deployment of AI. The trajectory of AI research suggests that the next few years will bring even more transformative breakthroughs. These emerging frontiers aren't just incremental upgrades, they're reimagining how AI integrates with human expertise and physical systems. Key areas to watch include AI-augmented development environments, systems that collaborate with programmers to design, debug, and optimize code in real time. Neurosymbolic architectures, hybrid systems combining data-driven learning with rule-based reasoning for auditable decision-making. Autonomous robotic systems, machines capable of self-directed learning and adaptation in dynamic real-world environments. Quantum AI integration, exploring how quantum computing could solve optimization problems intractable for classical systems. As we continue this journey, one truth emerges. AI's future hinges on balancing raw capability with societal trust. The collaboration between academia, industry, and policymakers will determine whether these breakthroughs uplift humanity or deepen existing divides. That wraps up this episode of AI Frontier, Navigating the Cutting Edge. Today, we've explored how groundbreaking research is reshaping artificial intelligence, from architectures that think like humans to systems that accelerate scientific discovery. In our next episode, we'll dive into open source AI evolution, where collaborative development is democratizing access to cutting edge tools. You'll discover how global communities are tackling challenges like ethical alignment and energy efficiency while pushing AI's boundaries further than ever. Thank you for joining me on this journey into AI's frontier. Until next time, stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.